tasks. Actually, yeah, a lot of people later need to graphically represent the amplitude spectrum. So now it's a new thing, and it's the main thing of this laboratory work. So you need to use the function FFT. So it means that you can go from, you can show the signal in a time domain, and also you can show the signal in frequency domain. So you need to switch and create the two different graphs of the same cutted segment of signal. So first one is in time domain, second one is in frequency domain. So let's look at how we can use this FFT function. Yeah, and there's also a few different types of your task. Maybe you need to work with a audio segment, or maybe you need to just create a few sine waves. Now maybe we can look for that variant where you need to create the sine waves. But actually it's the same what's happening later. So now, for example, I'm having the variant where, let's say, I have a three sine waves, different frequencies. It's, for example, 47, 83, and 101 hertz. And let's think that my sampling frequency is 2000, and I'm creating a time vector for 2 seconds. And yeah, here I'm making a time period, 1 divided by sample rate. Okay, so here I'm creating a three sinus waves, and here I make different amplitudes of these sine waves. Okay, and here I just creating the one sine wave, the sum of these sine waves. Yeah, and now I want to see, for example, how it looks like with sum of the sine waves. Okay, maybe I can. Let's try now. Just look Y4. So it's just the beginning of the task. So here is the combined signal of the three different sine waves. Okay. And now I need to make it, I need to convert it and to use the FFT function. So how it looks like. So, okay, I will show you everything step by step. At first, yeah, the function FFT, here, you need to put the two variables inside it if you want that it works. So the first one is the cutoff audio segment, or the sum of all the sine waves. So it's the signal meanings. As you see here, I made a sum of 3 sine waves, and I put it here in an FFT function. Second one, it's the length of FFT. So you can do like that. I created a new vector L, and it's the length of Y4. So it's just the numbers of samples, how much samples has this. And actually, sometimes you can find in some video tutorials that this points number, samples number need to be a little bit bigger. So you can actually experiment with it. You can multiply with a 2 and make it a bigger. Actually, it depends on the resolution of FFT function. When later you will see the spectrum, So how, if you have more points here, so you will get the better resolution of FFT. But you can start from this. Okay, so we can see now what's happening if we do like that. Let's look to the plot. If we can, at the beginning, don't have nothing in the x-axis. Okay, let's try just plot the results, FF. So in this case, we are getting really strange graph. It is because that the new variable FF, it's a complex variable. It has not only the meanings of frequency, but also has a phase information. So we cannot plot it like different like that. So if we want to see the frequency information, we need to plot the module only the positive values. So we need to use a ABS function here inside. Let's try now. Okay, now we have a spectrum of the signals. I have a 3 sine waves. Actually, it's the also interesting thing about FFT, that FFT, it's a fast Fourier transform. And when we doing simple like that, we get the mirror image. So we have our spectrum here, but we have a mirrored spectrum in the opposite side. So I don't know, maybe in a theoretical lessons, Professor Minotas maybe tells you a little bit more about the fast Fourier transformation, how it is working, and why it is happening so that we have the mirrored view. So now maybe we don't go deep into that, but what we need to do now, actually, we just need to cut the half of this and just ignore the second part and look only to the left side and ignore right side. Yeah, so how we can do that? Okay, one moment. So if we want to ignore one side, we need to cut half of it. So we can create a new variable, for example, FFF, and we assign only half of the meanings. So we assigned from variable FF the samples from number 1 until the end, until the L, so it's how much samples it has, and divided with 2. So now let's try to plot new variable FFF divided with 2. Let's look how it looks like. One moment. Where is my new graph? Okay, maybe I need to clear old variables. Let's try to. Yeah, sometimes it happens that maybe I need to close my MATLAB and open it from the beginning. Sometimes it can be. Okay, let's look to the chat. Okay, what is a Y for? Yeah, so I see that a colleague answer for you, as you see it here. So Y1, Y2, Y3, it's the free sinus. It's a free sine waves. Okay, we can, yeah, maybe I will, look, I will shut down the MATLAB for a little bit and turn it on again, restart, and I think it needs to work. And I can go to this section again a little bit. Okay. Let's try to open MATLAB from the beginning. So is it clear about that task? Yeah, it's some signal of some sine waves. Okay, we have 9 minutes left for the first part of our meeting. So when we finish, we will make a 5 minutes break, and after that we will come back here. Okay, and during that break, maybe you can do something by your own, and maybe you can have questions. And when we come back, you can ask me that questions. Yeah, okay, so now I restarted MATLAB, and now I will try to run this code from the beginning. Yeah, now I'm having, as you see, what I have done here, so I cut it. Can you look? Do I need to look for this, or are you just discussing to each other? So you actually can share your screen, and we can look everybody what you want to show.
So, can you hear me?
Yeah.
Okay. So I did that part where you do the amplitude spectrum, and if you can see on my end, it's like those two spikes are really far apart. Is that what it's supposed to do? Like, I don't really get why you have 600, although like that 600, I guess, is the length, right?
Yeah, now it's I think here you see just sample numbers now. So we now will go on how to convert it to frequencies. So yeah, now you need to divide it by 2 to just ignore that part, the right part. Now I just showed you how to do it. One moment. Oh, now okay. Yeah, you need to do like this here. Ignore half of the vector, half of the values. And now let's look how to convert these. Yeah, actually look. Now I have my frequencies 47, 83, 101. When I see to my frequency spectrum, so you look that it's not that frequencies. It's 200, 150, something like that. It's not the frequencies still in the x-axis. You need to convert. It's a samples, just the samples. We need to convert it to frequencies. So how you can do it? Here is the function how you can do it. So we creating a new variable xFFT, for example, and we will put it here in the plot graph. We want to put it in an x-axis, xFFT, and here the meanings, ABS, FFF. So you need to create the vector from 0. Actually, you can create it also, for example, from 1 to L divided by 2, because we want to ignore that mirrored image, or like we have done it in a time vector. I know, maybe you can look, maybe it can be not so accurate. And if you want to start your graph from the 0 and until L divided by 2, so you need to make -1 here, because it will be one sample, it's too much of one sample. So you need to divide it here and multiply with the sampling frequency. Sorry, here we need to minus one. Okay, here multiply with sampling frequency and divide it from the length. And after that, you will get the frequency spectrum in x-axis. Let's try to look now. So remember my 47, 83, 101. Let's look. So I think that now it's working. Yeah, 47, I think it's like that, something, 83 also, and 101. Now we're seeing the frequencies. So here, and it's really important that in the end of the task, now I'm not writing it, but when I will see your final results, I really look for it if you label the x-axis and y-axis, because it's really important that you need to understand, for example, when you're analyzing the signal in the time domain and in frequency domain. So you need to understand that in x-axis on time domain signal, it's a time in seconds or milliseconds. And here now in frequency domain, it's a frequencies. So you need to write that here is the frequencies in hertz. And when you are in time domain, you need to write here that it is the time in milliseconds. So it's really important to understand what is the measurement units here. Okay, and so now, okay, maybe I will have a few minutes to talk about amplitude. So actually, we don't also understand what is here. Actually, it is also a sample numbers. It is a sample numbers, and the easiest way what we can do, we can just normalize the amplitude. So we can do that the lowest amplitude is 0 and the biggest amplitude is 1. So how we can do that? It's a normalization process. So it is the code. We just divided all vector of meanings divided by maximum value. So we looked what is the maximum value of meanings and all the meaning vector dividing by this maximum value. In that case, we're getting that the maximum value is 1 and the lowest, the minimum value is 0. So let's look how it looks like now, the graph. So as you see now, you can write actually that it is the normalized amplitude. And as you can see, we made here that the 47 hertz has amplitude of 2, 83 hertz has amplitude of 4, and 101 hertz has amplitude of 3. So here we can see that amplitude is now correct. The maximum is 4, so we have it like maximum like a 1. And when we get the amplitude of 2, so we had half of it, half of a maximum, and so on. Maybe there is a way. Actually, yeah, I think it's a way how we can normalize and make the same amplitude as here. So we just need to maybe modify this code a little bit. Maybe you can do it like that. It will be okay also, but you cannot leave the samples. You need maybe or normalize or something like that. Okay, the first part of our meeting is going to the end, and Zoom will shut us down. So let's come back after 5 minutes, okay, and think about your questions, what you want to ask. Okay, try to do by yourself.
When do we come back again?
So let's do it in 5 minutes. How much time we have now? 11. So 5 minutes after 11. Okay.